Okay, in section 5.2, we're going to use the opposite of the chain rule, or we're going to undo the chain rule to find the integral of some more complex functions. And so the idea is that if you're taking the integral of something that can be written as u to the n times du dx, then that's the same as taking the integral of u to the n with respect to u. And of course, if you're taking the integral of u to the n with respect to u, that would be u to the n plus 1 over n plus 1, and then plus a constant. And then once you've found that integral, you can plug back in for x. And that will give you the integral with respect to x. And so here's our first example. We have the indefinite integral of x minus 3 raised to the 7th dx. And of course, we could FOIL this out, x minus 3 times itself 7 times, and then take the integral of that. But that would be a huge hassle. And so what we're going to do is we're going to do a u-substitution. We're going to let u be x minus 3. And then if u equals x minus 3, then we can calculate that du dx is equal to 1. All right, the derivative of x is 1. And if du dx equals 1, if we multiply both sides by dx, then we have that du is equal to 1 dx. Okay, so this is kind of the side scratch work. And now that I've done all that scratch work, I have that this expression is equal to u to the 7th, because u was x minus 3, and then dx is du divided by 1. So let me put this another way. du equals dx. So dx I can just replace with du, because those two things are exactly the same thing. Okay? And now you can take the integral of this. You get u to the 7 plus 1 is 8 divided by 8, and then plus a constant. And then all you have left to do is to substitute back in for u. So you get x minus 3 to the 8th all over 8 plus c. And that is because you've substituted in x minus 3 in for u right there. Okay, and so this is your final answer. So we found that the integral of x minus 3 to the 7th is equal to x minus 3 to the 8th divided by 8 plus a constant.